So this problem says to state the reference angle for each angle in standard position. The first standard position angle that's given is 55 degrees. So we know that the positive x-axis is considered 0 degrees. Then once you're going in the counterclockwise direction, this is a 90-degree axis. Over here, the straight line makes 180 degrees. And then continuing on 90 degrees past that is 270. And then back to 0 is a full 360 revolution. So 55 degrees would be between 0 and 90 degrees. So the reference angle, so the terminal arm we can draw in quadrant 1. It doesn't really matter where we draw it. We just know it's going to be between 0 and 90, so we can draw the terminal arm here. The reference angle is always going to be between the terminal arm and the nearest x-axis. So that is this angle right here. So since this angle is 55 degrees from 0, that means that the reference angle for 55 degrees is also 55 degrees. And that's going to be the case for any angle in quadrant 1. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Any angle with the terminal arm in quadrant 1, the reference angle is equal to its angle in standard position, because your angle in standard position always starts at 0 and goes up to the terminal arm. If you haven't passed 90 degrees, that's going to be your reference angle. Moving on to part B. Part B is 155 degrees for the angle in standard position. So 155 is between 90 and 180, so that's going to be somewhere over here in quadrant 2. So for 155 degrees for the angle in standard position, that's going to be the angle from the positive x-axis to the terminal arm. This represents 155 degrees. But our reference angle is always from the terminal arm to the nearest x-axis, which in this case would be this angle right here that I just identified as theta. So if this angle, if from the positive x-axis to the terminal arm, if that's 155 degrees, we need to figure out how much further we need to go to get from 155 degrees to get to a full straight line, which is 180 degrees. So how much further do we need to go to get from 155 to 180? We can do 180 and subtract out the 155, and that gives us this angle right here is a 25-degree angle. So that would be for our part B. This piece right here would be 25 degrees. So in quadrant 2, you can remember a rule would be you always do 180 minus your angle in standard position when you're in quadrant 2. So that's one way to think about it. But I prefer to think about it as the pieces, how they fit together to make the whole. So like 155 plus 25 more makes 180. Let's try the next one. So the next one is 255 degrees is our angle in standard position. So that's going to be between 180 degrees and 270. So we're going to be somewhere here in quadrant 3. And we know that we're 255 degrees. So this is 255 degrees. So how much further past 180 did we go? Well, 180 plus what is 255? We can find that by doing 255 minus 180, and we get that this angle right here would need to be 75 degrees, because 180 plus 75 more makes 255. So what we just found was the reference angle, because this is the angle between the terminal arm and the closest x-axis. So this one would be 75 degrees. So notice that I'm finding the angle between my terminal arm and the nearest x-axis, not the nearest y-axis. I'm not looking for this angle over here, because that is the angle between the terminal arm and the nearest y-axis. That's not what I want for the reference angle. What I want for my reference angle is the angle between the terminal arm and the nearest x-axis, which is this angle in this case. Okay, so now there is a part D, 355 degrees. I want you to try that one. Try 355 degrees as the angle in standard position. Let me know down in the comments what you get for the reference angle. Okay, well, I hope this homework helps, step-by-step solution was helpful. If it was, please leave a like and subscribe to my channel for more videos that are similar. If you have a particular question that you would like to see a video for, you can either leave that in the comments or you can send me an email at the email listed in the description for a problem that's harder to send in the comments. Well, thanks for watching and happy studies.